Alright, welcome back to the Blender 3 Docwalk. This document is on transform orientations. So let's jump right in. Okay, so the first thing we're going to show here is this drop down right here at the top. This is global, or typically is defaulted to global, right as you start it up, as I just did. This is your transform orientation selection. Okay, and so we're going to go through each one of these and talk about them, but before we do that, I'm going to jump over here and turn on, nope, wrong one, yep, this one, okay. We're going to turn this one on, because this shows us our orientation. You know what, nope, we're going to turn the rotate one on. We're going to turn both of them on. There we go. Okay, before we move on, I want to draw your attention to this entry here. If you are following along with the documentation, this may be confusing, so let me explain why it's confusing. This says, for example, when you press X during the execution of the operation, it will constrain the transformation to the global X-axis, but if you press X a second time, it will constrain to your transform orientation's X-axis. This doesn't hold true, but there's a reason why. So remember, first time, according to this, the first time you press X during the transformation will constrain it to your global axis. The second time it will constrain to your transform orientation's X-axis. Let's see what happens. Well, our transform orientation is set to global. So in this situation, when you use your constraints, okay, when you're locking it to an axis, only when your transform orientation is set to global will the first axis lock it to the global axis. Second axis lock will lock it locally. Only when it's set to global. If I set it to local, for instance, and I tap S for scale, we're scaling, I hit Z once, it is along local Z-axis. Then Z again, now it's global Z-axis. See, it's the other way around. Don't let that confuse you. I just wanted to clarify that because, yeah, I mean, it can be confusing, right? So, okay, so now that that's out of the way, let's get moving. Okay, so what are these alignments? What are these orientations? All right, so we're going to jump back up here and we're going to turn this back onto global. And you should probably already know this by now, but you know, for the benefit of anybody that just is, you know, jumping around or looking up specific topics, your global orientation is simply just that. This is the navigation gizmo. I also call it the compass gizmo, but what that is the alignment of the global space. You'll see that the y-axis, right, aligns with the y-axis, x with the x-axis, and if we hop over here and turn on our z-axis, we can see that it aligns with the z-axis as well. So when your transform orientation is set to global, any transformation you perform on your object will be in relationship to the global space. So if we, all right, S for scale, scale is always kind of the easy one to do. If I tap X, that is to the global, it's locking to the global x-axis, Y to the global y-axis, Z to the global z-axis. Now remember what we just said, if I do X twice, it will go from my selected orientation to the local orientation. So that's global space, right? Global orientation. Jumping down to local. Local is just what you think. If I tap S for scaling and I hit X, it is now scaling first, right, to my local x-axis. So if I alter my object's orientation, right, let's rotate it a little bit, and we're going to rotate it along the z-axis this way. So now it's pointing this way. Now my object's x-axis is pointing this way, right? Okay, so let's try that one more time. Let's tap S for scale, and then I'm going to hit X. Now it's first going to perform the orientation along my local X-axis, which is this way. If I tap X again, now it's going to lock it to the global X-axis. So hopefully you now see how that works. The object's internal local orientation is mostly not aligned to your global coordinates. It has its own internal set of coordinates that you can use to align it and transform it. Okay, next is normal, according to the normal of the object. Now when you're in object mode, the normal, unless you alter something else, typically the normal in object mode is exactly the same as the local orientation. So again, if I've got it set my orientation to normal. If I tap X for scaling, and I tap, S for, did I say S or X? X, whatever. S for scaling. I'm going to hit X for for locking to that axis, and you'll see that it's scaling along the X-axis of the normal, or in object mode of it's typically the same as the local orientation. If I tap it again, we are going to move along into manipulation of the object according to global space. Okay, now to understand what a normal is it is the orientation of each individual. Here, let's jump into edit mode really quick so we can kind of explain this. You know what? We're going to go, let's not make this confusing. We're going to undo the orientation and the transformations really quick. Drag it to the middle here. Okay, now we're going to jump into edit mode. Okay, so I've got it set to normals, right? I'm going to select one vertex, and you'll notice that it's kind of got its own little odd orientation. And if I'm going to turn on X-ray vision here. If we select them all, you'll notice that each one of them seems to kind of be oriented to point away from the center of the object, and that is not on accident. Let's get it back here, because the normal of this vertex is in fact oriented in that manner. If I select, what a normal is it is the average of the two orientations. And of course that gets into matrix algebra, but without getting too confusing, you'll notice it should be obvious that let's look at this kind of, to really kind of understand what's going on here. It should be obvious that if I've got if I kind of look at it from the side here, if I've got its x-axis shooting off that way for that one, and this one's x-axis shooting off that way, well, one going this way, one going that way, the average together should be that way, correct? And if you look at the other two, it's a very similar sort of a dynamic. So as you begin to add them all together and average them all out, you get what is this local orientation. And that is the normal of the entire cube. It is the average of all of the normals of all of the vertices of that cube, averaged out, come together. Without throwing a total wrench in the gears, that's not how it always works. But don't let that confuse you. That's much later, and that is some territory that I am not totally comfortable with either, so we're going to be learning a lot about that a little later. Anyway, moving on. Okay, so that is that. We're going to jump back into object mode, and we're going to go down to Gimbal. Okay, Gimbal it takes a second to kind of get used to how this works. So I'm going to pop open my my side panel here. Remember, the side panel was opened by hitting N on the keyboard. Okay, and we've got a few things that are relevant to gimbal orientation. So right here we have XYZ Euler, right? So XYZ, XZY, YXZ, YZX, ZXY, ZYX, and axis angle, that's separate. That doesn't work the way these other ones work. But what gimbal is gimbal allows you to rotate your object in a gimbal-like manner. Okay, here's the Wikipedia entry for what a gimbal is. I'm going to hop over to the next tab where I've got the this animation opened. So you can see in this animation that the axes, the way they're configured, do not always, line up perpendicularly to the other two axes. So the center Z axis is going straight up and down, but we've got it's difficult. You've got this this axis, which could be the X or Y axis, kind of like rotating around, and then it's connected to the next gimbal out, which kind of holds the last final axis. That's just kind of like flipping all over the place. So that's the kind of configuration we're talking about. It's more based on each consecutive axis anchored to and only to the previous one. Does that make sense? It's kind of like a hierarchy, right, of how the axes interrelate. So that is what we're talking about. Okay, so we are, our orientation is set to gimbal, and if we look over here, we've got our rotation order, okay, XYZ Euler, and you'll see that there are multiple Euler orientation orders, or axis orders, rotation orders, XYZ, XZY, YXZ, blah, 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 right, all the way down. So what this means is that X, in a gimbal-like fashion, okay, is linked to Y. So X wholly it's perpendicularly locked to Y. What I mean by that is if I come over here and I rotate around the X-axis, you'll see that none of the other axes are rotating with me. However, if I grab the Y-axis and I rotate it, you'll notice that the X-axis is the only axis that is locked to the rotation of my Y-axis. And so in that way, it is locked perpendicularly to the Y-axis. And likewise, the Z-axis, because the Y-axis is locked perpendicularly to the Z-axis, and the X-axis is locked to the Y-axis, rotating the Z-axis rotates both of them in whatever configuration they are currently in. So with our rotation order, we can alter that hierarchy. We can alter how that rotation order works. So if I do ZXY, it'll work in just the other fashion. Okay, it'll be Z. The Z-axis is wholly and completely independent. Okay, I can rotate it all I want. The other axes are not locked to it. And then, then the Z-axis is then locked to the X-axis in that manner. Like if I alter the X-axis, the Z-axis will follow. And then, likewise, X to Y. So if I grab the Y-axis, where is it? There you are. And I rotate it, the other two will rotate because, Y is locked in such a way to that chain, that it will move all of them because Y is locked to Z, and then, or Y is locked to X and X is locked to Z. All right, so, yep, that is gimbal. And of course, as you modify or manipulate your object, like, I'm going to scale it up according to the z-axis, lock it to the z-axis, or the x-axis, or the y-axis. They all seem to be along kind of the same direction, because they are all kind of lined up in a similar direction, except for, well, nope, not the x-axis. But yeah, so that is how that works. Next up is view. This one is really easy. It is simply the orientation of your view screen. You'll notice that the X and the Y indicators are directly aligned with how we are looking at it. So I'm going to pan around and show you that as I pan around, the X ring here and the Y ring will kind of curve perspectively according to where that is on our scene. You'll see what I mean here in a second. Okay, so here we go. We're kind of panning around, and you'll see that see how it's kind of bending and moving according to the perspective of where it's located on the scene. That's because if we move it right to the center, there, about there, and right about there, because that is the center of our screen. So no matter how I rotate it, that is going to stay that, because it is the orientation of our screen. Z being looking directly down onto it. So if we let's kind of get this not confusing looking really quickly. So yeah, you'll notice that the z-axis will always point in our direction, right? So if we want to kind of center it here and then move it, tap G, and then we hit Z, we're moving it close and then away, close and away. That's because its z-axis is jutting towards us. And finally, come down to cursor orientation. So the cursor, let's hop down to view. Okay, we can see here the location and rotation of the 3D cursor. So the transform orientation, when it's set to cursor, aligns to the rotation or the orientation of the 3D cursor. So of course you can manipulate the orientation of the 3D cursor, and see as we were tweaking the 3D cursor's orientation, the orientation of the cube that it is being aligned to also is being manipulated, because it is based on the orientation of our 3D cursor. And lastly, we can create our own orientation or transform orientations by hitting the plus sign here. So whatever you have selected, when you hit the plus sign, will be the default orientation upon which the new orientation will be based. So for example, let's add, let's add a cylinder. Okay, grab it, move it over here. We're going to size it up a bit. And let's go back to local just for a second. And let's just move it the other way. So its X is global Y, and its Y is global X. And now we're going to come up here and do, we're going to create a new one, new orientation. It is named cylinder, but because we haven't done anything else yet, we're going to go down to our last action options here. We're going to name it Sil1, and it's checked as use after creation. So once it's created, this is the orientation that it's going to be using. And this last one is Overwrite Previous. What this means is, if we had previously done it and there was already another cylinder right, another orientation called cylinder. We did it with another cylinder. When we do this, if we click Overwrite Previous, the new cylinder's orientation will overwrite the previous one called cylinder. If we don't click on that, then it will give us a new one called cylinder.001. And so if we write sil1, actually, let's just, nope, that's fine. Oh, okay, C1. Just do C1. That's easy. Okay, and yep, that sucked. Everything's good. Okay, so it is C1. So if we click on that, you'll see that its orientation, right, how we are going to manipulate it, is in fact the orientation that the cylinder has been set in with the its Y as global X and its X as global Y. The other option, as we create a new one, we're going to create another one really quick, and we're going to call this V1 because we are going to turn this off, or no, we're going to keep that on, and we're going to click Use View. Now you see immediately it is centered and aligned to our view, to the viewport, just like with View, right? Just like with the View transform orientation. But the difference is that once this is created, that is its orientation, okay, from which we were viewing at. But it does not change with the view anymore. It is oriented to the view we had when we created it. And I guess just to I don't know, just to really cement this and I guess give an example as well, we're going to just do another one. Nope. Okay. We're selecting the cylinder. We're going to go down and create one as a cylinder, right? We're going to turn off Use View, and we're going to overwrite previous. Nope, we're not going to overwrite previous. We are not going to overwrite previous because that's what I want to show you. All right, now you see that it's up here. It says v1.001, and that's what I wanted to show you. That if you do not overwrite previous, but it has the same name, it will append the 001 to the end of that of the new one's name. All right, so that was the Transform Orientations document. I will see you guys next time when we talk about the pivot point. So again, thank you for watching. Please like, share, and subscribe. I will see you guys next time.